You want me to start with part 1 or just move to part 2?
I think it's part 2.
Yeah, we can just do part 2.
Want me to start?
Sure.
Okay, so number 1, design the study. Okay, so I have to tell you honestly, like last week I thought I was doing okay, and then when I got to the homework assignments, it totally just didn't even make any sense at all. So I like reread everything, but I'm meeting with a tutor tonight. So anyway, I'm hoping that my information is okay. So design the study. Match criteria feature. A manager at a factory feels the amount of time his workers spend doing their part in the assembly line is too long. He measures the amount of time in minutes 9 of his workers take to complete 100 products. After implementing the new procedure, he again measures the amount of time in minutes the same 9 workers take to complete 100 products and obtain data. He wants to know if the mean assembly time is different and used the level of significance of A equals 0.05. Use data link on brain, honey, factory assembly times, Sims for SPSS. Blah, blah, blah. Anyway, so design the study. Okay, so what is the research question? And I wrote, does the new procedure charge or change the time it takes to make 100 products using 2 different setups?
Yeah.
Yep.
That's about what I think.
Yeah.
Yeah. Plus,
I put, does the mean time after differ from the mean time before?
Yeah.
yeah, that's what I put.
Mm-hmm.
Or does the new procedure change it? So yeah.
Yeah, good job.
And then the null and alternative hypothesis. Is there an echo on someone's? Is it mine?
You know what?
I'm hearing the echo.
I'm hearing a little bit of the echo, but I don't know if this was the same with Adobe Connect. We had 3 of us had headphones and 1 didn't, and there was a crazy echo until the one that didn't have headphones went off, and then all of a sudden there was no echo with all of us. I don't know if maybe it's us with the headphones that are causing problems this time.
Oh, I don't know. Anyway, the null would be equals 0, and the alternative is that it does not equal 0.
Very good.
Yep.
Okay, so describe the data collection procedures. I put 9 workers are timed to see how long it takes for them to complete 100 products. And then a new procedure is introduced and used, and the same 9 workers are timed to see how long it takes to complete 100 more products, and the times are compared.
Yeah.
Yep, that's basically what I put.
I feel like on those everyone's answer will be like slightly different, but it's like the same.
Yeah.
Thing. Luckily, I should just like click on one of the options on the test. You don't have to like write on it.
Okay, so number 3, describe the data. In a short paragraph, use summary statistics to describe the data. After the paragraph, insert an appropriate and well-labeled graph to illustrate the data. So, let's see. I think I printed my graph off here. I think this is my graph.
Yep. That's what mine looks like.
Does that look right?
Yep, that's my hand-drawn one.
I was gonna like try to show it. It's like mine has a little bar and then a space and then some bigger bars and then little bar.
That's awesome. Okay, so then I just put So the statistics, I have the sample mean difference at negative 1.0556.
Mm-hmm.
And then with the standard deviation or a sample difference, how do you say that? Sample mean difference of 2.5952 with the sample mean of 9.
Yes.
Or the sample size of 9.
Yeah, that's what
Yeah, the sample size. Sorry.
I knew what you meant.
I keep mixing those up.
What were you saying, Manette?
I was just going to say, would you mind, how did you get that? So I put A equals 0.05, we're using alpha. And then the D, the difference bar, how did you get the difference bar?
So,
In SPSS, right?
yeah, just in SPSS.
My SPSS hasn't been working, so I talked to Kirsty about it tonight. She doesn't know. I'll have to talk to somebody about it. But anyway, go ahead. Sorry.
Yeah.
The SPSF I found to be more successful for me. I understand it, but I mean, Karina, you seem to use Excel more?
I do. Yeah.
The one thing that I do like about Excel over SPSS is that you really don't have to do a whole lot of downloading to get it to work.
And I've never even tried Excel. I've just always used SPSS.
I didn't either until last time. It was so much easier to put in the information into Excel when we were getting the P-score.
Yeah.
You know, especially if you're saying less than or more than or equal to. It had one more feature that the SPSS didn't have.
Yeah. I know, I keep thinking I should try it so I know how to do both, but I never take the time. I just do what I know.
So I can get SPSS on like a different Windows computer, but because my laptop is an Apple product, Excel is a lot easier. So do you have is yours an Apple computer? Is that why it won't work?
So I downloaded it onto my computer, and it's a Toshiba. But it never really worked. I don't know why.
Maybe that might have something. I know that you can call. Where was it? There's somewhere on campus that you can call, and they can help you walk through it.
Yeah.
I'll call you tomorrow.
So.
Okay.
I mean, I got it.
Did you guys get the same on 3 though? The other 2 of you?
What's that? Oh yeah, I got the same thing you did.
Yeah.
Okay.
Sorry.
Okay. Let's see. And then what type of, number 4 is make inferences. So what type of hypothesis test is appropriate? And I put a matched pair t-test that is two-tailed or two-sided.
Yeah, that's what I put.
I put use both sides.
Use both sides?
Mm-hmm.
Yep.
Yeah. Sorry.
So B, what are the requirements for this test? And I just put the sample mean for the difference comes from a normal distribution.
Mm-hmm. Which does, I mean, I continued on, but then when you go to the answer key, when I went to check, they actually have an additional C question here that just asks whether or not it is normal or not. And I actually had looked, and I'm having a hard time reading the QQ plots because I'm like, okay, you know, as they're explaining it in the video, and he's like, yes, see, look here, you know, we have 15 samples, but you look at it and it looks normal, but there are dots all over the place. I'm like, okay, that's what normal looks like. I guess that would be good. So when I looked at the QQ plot this time, I went, I guess it could be normal. It looks that way. And then, of course, it's not normal. So if we have to scrutinize a QQ plot, don't rely on my ability to tell whether or not it's normal. Because I'm really not quite sure, but apparently it is not normal.
I think because when you draw a straight line, like a lot of the dots are missed.
Yeah, they're kind of off and on.
Yeah.
And that's why I had watched the video where he had described the sample size of 15, and it had the same thing. It had a bunch of outliers, but maybe with 15, because there's more that are closer to the middle, he could call it normal. But yes, it's not normal. Okay, so compute the differences between the two times and determine if the requirements are met for this test. And explain your answer. So C from the homework, or not the answer, but from the regular homework assignment, says continue with the test regardless of what you found in part C, and compute the statistics test. And so I just took the T-score from the SPSS, and that gave me the negative 1.220.
Yeah, that's what I got.
Yeah. I left off the O, but yes.
You did what?
I left off the O, but if it tests, I think we would leave on the O since it says round to 3 spaces.
Yeah.
But I didn't write it down.
You rebel.
Alright. So then the degrees of freedom, I got 8.
Mm-hmm.
Okay.
Yep. And then it says compute the p-value to the alpha level, and I got p equals 0.257. And so the p-value is greater than the alpha level.
Yes.
Yep.
So then on F, we would have failed to reject the null because it's not lower than the.
Yep.
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 And then it says, do you reject the null hypothesis, fail or reject? Do you have to put a reason why?
I put insufficient evidence.
Okay.
Yeah,
I was
insufficient
about to
evidence.
write something long. I'm just lazy.
I put insufficient evidence to say that the new procedure changes the time to make the 100 products.
Perfect. Okay.
Yeah, that's basically what I put. Give or take a word.
Yeah. Okay, and then H says, rather than testing a hypothesis, now say you just wanted to estimate the mean differences between the wait times at 95%. What would you do? Do it and paste your results below. And so I just said that you would take the 95 confidence interval levels, and I got a negative 3.0508 as the lower, and a 0.9397 as the upper.
Now, can it be opposite? Like the other one could be a negative, and is that right? So it could be either way?
Yeah.
Oh, I remember. Okay.
Yeah, it seemed like it could be either way, like whichever way you subtract it.
Yeah.
Yeah, that's
So I
good.
think as long as those are the levels we got, either way we listed it could be fine.
Yeah.
I think so.
But the one thing I noticed on SPSS is it will stay lower and higher. So regardless which way you put it in.
It still states it the
So
way.
I just kind of go from there.
You know, it's interesting because on the videos, he had you put the post, so you do the post minus the pre, and not the other way around, or I guess he didn't do it the other way around, but that would have been my question. Couldn't you do it the other way around? I mean, the numbers would flip-flop, but on the answer key, it did show the two different numbers, so I'm assuming that you could.
Oh, I've always done
Right.
I always did the pre minus the post.
You did? Did you come up with the different numbers or the same numbers?
No, same ones.
Hmm?
Did I do it? Wait, wait a second. Now I'm second guessing myself. What did I do?
I think we've decided that second guessing is kind of our thing, and it's not a bad thing.
Oh dear. Okay, wait. Okay.
Let me see.
Because I think I. Hmm. What did I do?
I don't know if it's because how I put it in to compute it, but I mean, on mine it's specific negative 3.058 or 0.0508 and upper bound 0.9397.
Yeah, that's what mine came up to be. So I'd be curious to go back and see if I just put in the pre first and then the post, if that changes the numbers at all.
Yeah.
Because then I guess then that would mean, well, you know what? It would still, I guess, make sense. Because, well, it's not really a T-score, because T-scores and Z-scores you can flip-flop.
So
Because,
in the reading, in the book,
yeah,
here's the example in a graph that says subject 1 post, talking about weight, 56.1, pre, 62.5, difference, and subtracting the post from the pre to get a negative 6.4.
well, maybe we're just
I was just going to
overthinking it.
re-put it in.
See if it changes anything.
Yeah, see if it changes anything, because I still have it pulled up. Oh, maybe this is a different one. This might be from homework. My numbers were completely
That's when you
different.
have to double stuffed up last time.
Yeah. Okay.
Let me see.
Yeah, that didn't help me.
I'm using the T-scores. Yeah, on the answer sheet, it does give the numbers, give the positive and the negative numbers flip-flopped.
Yeah, it does show either or.
Let's see.
So maybe we get it right either way.
You what?
I said maybe we'd get it right either way we put it.
It's true.
It doesn't seem to really matter.
No, I don't think it does. I don't think it does.
Okay, on the last one, I wrote the action you feel should be taken. Please tell me statistical result for that. And I wrote something like, look at doing another procedure, one different.
That's pretty much what I have. I said new procedure. The new procedure didn't make a significant difference. Give a recommendation for a new procedure. A new procedure needs to be found and tested that will increase or that will change time.
Yeah, that's pretty close to what I had. So do we want to jump on and do the quiz?
Yeah. Yeah.
Let's see. Do we need to pull up anything first? I don't see that we do.
Hold on, I'll be right back. I'm so sorry.
That's okay.
You're good.
So we do.
Yeah.
Sorry, I opened it, and we have to open Chapter 12, Data A.
12 data A.
Yeah.
Oh, I'm good. Thank you,
You
sweetheart.
sure?
Yeah.
No, I'm not even going to open the wrong thing.
Is there a name to it?
Um,
Or is that what it says?
Am I looking at the wrong?
it's for questions 5 through 10. There's data A and data B that we have to open.
Let's see. That's so funny. I don't know.
Chapter 12, Data A.
Chapter 12 data A. Where is that at?
So if you go to the
I know, I'm trying to find
UAI statistics, it's
Where?
Oh, yeah, I see
in
it.
okay. It's in the list of
So,
like
yeah.
Oh,
there's either SPSS or there's the Excel files.
Yeah.
and it's data files.
Let's see.
And then
Yeah, Chapter 12, Data A1.
Okay. So we need chapter A and B. Or we need just A?
And B.
We need them.
B later too.
Okay.
I just have it open.
Okay.
I don't even see it. Sorry, guys. Where is it? I'm in the data files, but
I just went to the homework and opened the AP AM PM heights tab and then found the chapter
Yeah.
12. I'm not seeing the. Did you open the quiz already?
Me?
Yeah.
Yeah.
Okay.
So that's
Yeah,
how
I've got it open
I
too.
wanted to see if there was
Got it.
anything that we had to pull open because I didn't see anything at the beginning, but I had a feeling that there was some.
Something. Got it. Got it.
Just because how else would that's I just assumed that there probably would be. Had a feeling.
Did I open the right thing? Which question are you seeing that we need that for?
So it's
See. Okay.
5 through 10 and
Got
then 11 through 18.
Got it. Got it.
So for more than half of the quiz, it's that information. I'm going to grab a piece of paper.
Okay. Here we go. You want me to go ahead and read number 3? Is everybody ready? Minette, are you on?
I'm ready. Yep.
Okay. Suppose we have a set of paired data. Let D equal X after minus X before. The null hypothesis is the mean difference equals 0, and the alternative hypothesis is that the mean difference is different than 0. The population standard deviation is unknown, and Jordan collects a sample size n equals 9 and computes D equals 2.2 and S D equals 3.3. What is the value of the test statistic? So,
I'm ready.
you ready?
Yeah.
Okay, so with N, do we not have a t-score? Oh, I guess t is 0, right?
What number are you guys on?
3.
3.
Oh, okay. I was like, what did I miss? Okay. Whew. So for this one, are we then plugging it into the sample t-test for means? Or the paired sample t-test, I mean. Is that what we're putting in, right?
The paired data. We have to set in paired data. It would be the question.
What?
I was going to do the statistics test that's d barred minus 0 is divided by the
3.3.
I guess the different standard deviation divided by the square root of the sample size.
Yeah, that's what I was doing for it.
So, oh, okay. So you guys were just doing it by hand.
Yeah.
Okay.
Yeah.
You check us on the computer. Make sure we're doing it right.
Well, is it? Okay. Okay. Let's see. You guys can check me.
So I got 2.
This is 0, not equal to.
I get 2 as well.
Ah!
I got 2 as well.
So did I. Yay!
Yay!
Woo!
So 4 out of 4, that's good.
That's a
I
pretty
love
good
it
indicator.
when that happens. Oh, it makes me so happy. Okay. So we just put 2. We don't have to put like 0.00 anything, right?
I don't think so, because I just got 2, straight 2.
Okay.
And we could put
And it doesn't say round or
2.2.
anything on that one.
You know, it's in the next question they actually give us the answer.
Oh, that's funny.
Oh. The
So do we
probability.
need to put 2.0?
You know what? We might as well.
Yeah, why not?
Yeah. Probability being greater than 2.2 is 0.0403.
Use use the alternate hypothesis to determine the t-value for this test.
So if it's
Man, they can go back to the old school stuff.
Okay.
So what do we do on this one?
Right? That's my question. What do they want us to do?
The probability of being greater than 2.
So if we do greater than, so then, oh, okay.
So then,
The p-value for this test. What the? Probability of being greater than 2 is 0.0403. Use a 2 to determine the p-value.
Well, I'm just not sure what we're doing on this one.
right? Confidence interval, margin of error.
Is that I'm sorry. Am I I feel like I missed something?
That's what I feel like. I feel like, wait a second.
Because that is the p-value. So I'm a little.
Well, that would be the t-score. So 2 would be the t-score.
Right. And then 0.403 is the p-value. Like, because if you on here, if I have the p-value and the t-score is 2, and I have it as greater than, the p-value is equal to 0.0403. So I'm confused what they're asking.
Yeah, I am too. The probability of being greater than 2 and the t-score is 0.043.
So would we change the null to 2?
What is the... let's see.
Okay, so it says right here in the book, find the value and compare it to the level of significance. Is that not it?
What'd you say, Manette?
In the book, when it talks about the level of significance, is the p-value, does that sound right? So it says p-value equals p times what the p-value is, and then times it by something, and then it has the less than sign, 0.05 equals A. I'm completely lost. I know what it's asking. I was just looking for the value and what it was saying about it.
Yeah, I have no idea what number 4 is asking. Okay.
We haven't had to determine the p-value for this test.
Okay, let's see. P-value equals the probability
We've been using software to do it, so I'm kind of...
But see, they use the applet
Yeah.
for their example.
But it's not the normal output, right?
Right.
How do we get that up?
Where did they use the applet?
In the book.
In the notes, when it's talking about the p-value, says for illustrative purposes only, this test statistic is labeled on the horizontal axis. The p-value is the area to the left of the t under the curve.
Mm-hmm.
Please note that this image was taken from the normal probability applet. The test statistics for two means with paired data is a t. This image was designed for a z-curve. This is not the right image for this procedure. For this reason, we labeled it for illustrated purposes only.
What the?
So I'm not even sure. But then it says find the p-value and compare it to the level of significance.
But again, that was after it had given us data to plug into.
Right. I'm wondering if it's not.
Oh, two, right? Huh. This is probably not even close to right, but I typed into the z-score on the normal probability estimate and got the probability of 0.0228.
Yeah, I plugged it into the applet and got the same thing. But
I don't know.
but we're dealing with a t-score, so I know it's not going to be the same thing. I mean, that can help us to know when we get close, but.
And the t-score.
Let's see.
Maybe we should come back to that.
Yeah. You guys want to just like pause on that one and move forward and then come back to it?
Yeah, that sounds good.
Okay. And we'll need to open up the data for chapter 12, data A.
Mine will open.
Okay, so use the data file of A, make a column of differences in the SPS, use the null hypothesis of 0, significance of 10. What is the D? Round to the decimals. So here we've got to compute the variable, right?
Yes.
So yeah,
So
transform the variable. Is that what it's asking? Done. Use the data in a question to make a column of differences in SPS. So yeah, you would go and you would transform the variable, and that's where you would take the group 2 minus group 1, and type. Or you can type in whatever you want, but I typed in differences, and that gives you another column.
Yeah.
So then D would equal. See, for D, I get 31, a negative 31.0250.
what the? Oh, I see what I did wrong. I was like, what the? Okay, go away. Go away. Okay. You got a negative?
Mine does say negative on it, but let me double check
Huh.
here.
See, mine just says 31.025.
You know what? Maybe that is. Did you put the group 2 minus group 1?
I just copied and pasted group 1 into group 2. Like, I just put it into the paired sample t-test.
Okay.
What did you get, everyone else?
So,
I can't open it. I'm sorry. Both computers.
Oh, that's right.
I'm so
That's
sorry.
right. Sorry, I remember that now. My bad.
You're great. I just did that.
Yeah, I did it
Okay.
I know
again.
how that
and it comes
goes,
up
because the
again.
first couple weeks I couldn't get SPS open, but
so
I can
let
get
me see.
Excel.
What was it asking you?
What is
What is the?
D bar.
Okay. What is the D bar?
I guess I'm looking at question 3. If you go back to question 3, and it gives you D equals X after minus X before. So you would do the second group minus the first group.
Well, I got negative 31.0250.
Yep, that's what I got.
Is that what you got?
So you got a negative, then?
Yeah.
Okay. So
But if
I must have...
But if it's anything like what we had just said about the numbers, I mean, you got the same number, it's just not a negative, correct?
Yeah. So, X
So maybe you
after
just.
X before.
So
Tell
I
me
put
again.
group 2 minus group 1.
Okay.
Is that what you did?
Yeah, I did group 2 minus group 1.
Okay. Let me just switch these around then, because I just put it in like variable 1 and variable 2, but I think I must have put them in backwards. So it must not work that way, where you can just like be willy-nilly.
Did you have the same number, just not negative?
Yeah. Yeah, I did.
Yeah, my notes give the formula to get differences as D equals X2 minus X1.
Okay. So then let me do this. Okay. I just put them in backwards in. Okay.
So,
Uh-oh. Oops. Sorry. Just a sec. Okay, so you got negative 31.025.
Yeah.
Okay,
yeah.
I say we go with it. Negative 31.025. So then,
What did you get for the difference, the standard deviation?
341.157.
Yep.
Okay.
Awesome.
And then the test statistic, I got negative 0.407. Oh no.
I got a negative. Wait, let me go back and double check that.
You guys,
Yeah.
what did you get for the different
Yep.
standard
I got
deviation?
a negative 0.407, so that would be the same, 0.40.
Yeah. Yeah. And then the p-value, did you guys get, because we're rounding to 3 decimal places, so it'd be 0.689?
Which one's that one for the p-value?
Yeah.
What did you get for
Okay, wait.
p-value?
What did you guys get on the standard deviation?
Standard deviation, we got 341.157.
Okay, that's what I got. You guys were just frozen for a while, so I wanted to make sure.
It's like, no, tell me what it is.
I know. I'm like, I can't hear you guys talking.
Here's a question.
Yeah.
For this p-value, oh wait, we're just getting differences. We're not looking for a less or greater than. Correct? Yeah. Okay.
Yeah.
Sorry.
It's
The
either
alternative.
equal to or not.
So for the p-value, I've got 0.689.
Yes. That's what I got.
There's no zero.
What did you get for the T?
0.689.
We got for the test statistic, we got 0.407. You could put a 0 before the 689. And then what is the correct decision based on this evidence? It would be to fail to reject the null. Because our alpha is 0.1 and our p-value is 0.689.
You guys keep freezing out.
Sorry, where are you at?
Well, I was just checking to make sure I got what you guys got on the others, and I did. So. Okay, so 7 is negative 0.407.
You got what? Sorry?
For 7, 0.407.
Yes. Okay. Sorry, my brain was on the p-value still. I was like, whoa.
Sorry. Did you get negative there?
I did get a negative.
Yeah, me too.
Okay.
Thank
And
you
then
for reminding me of that. I did not put a negative in front of mine.
0.689.
Yeah.
0.689. And then we failed to
Okay.
reject the null because it's bigger than.
Because it's higher. Well, yeah.
Wait, right?
No, because
It's the other way
we're
around.
using the alpha.
An alpha of 0.10.
Yeah. Okay. Sorry.
So we would still fail to reject the null.
Yes.
We're talking about 10.
Greater
9.
Oh, okay.
So in 10, suppose your alternative hypothesis is that the mean is greater than 0. What is the correct decision based on this
I don't know
evidence?
if you guys can hear me, but you're frozen again.
Oh.
We can hear you.
Yeah, we can hear you just fine.
Oh, really? Yeah, I
Yeah.
can't hear anything. So did you reject the null again?
I think
On
I just
10,
figured out how to do 4.
You did?
Yes. Okay. So we're taking the probability. So you're saying right here that the p-value is 0.0403, but if you're doing greater than or less than, you would divide that by 2.
Oh.
Oh.
So that's what I think that's what it's asking us. If you're changing the probability to greater or less than, that you would divide that by 2, because that's what we need to do here with the suppose your alternative is less than, you would take that p-value and divide it by 2. And then we would decide whether or not we would reject or fail it.
Oh.
So
I never would have guessed that.
0.02.
That's what I'm guessing right now, because that makes sense. I'm like, how would we figure out that greater without them giving us any information? If all they're giving us is what we have in front of us, that's the only thing that we could do.
Yeah, that makes sense, though. So did you get 0.020?
For which one?
4.
For 4.
Let's see, 0.0403 divided by 2. I got 0.020. Yeah.
Yeah.
Okay. Yeah.
So then 0.6887774 divided by 2. 0.344.
Wait, so what are you on now?
It would still be the same answer.
Which would?
For 10.
To fail to reject?
It's fail, right? If
Yeah.
it's large.
If the number is low, reject the null.
Okay.
So we would fail to reject the null because the number is higher.
Okay.
Yeah.
My brain always second guesses myself on it.
Right.
I know. Okay, now we need data B.
Okay.
When I try to open up SPSS or the file, Chapter 12 database, it brings up an empty Excel looking screen. Is that what you guys are seeing?
Mine has an Excel. I'm just doing it in Excel because mine won't, Apple won't open up the SPSS.
But I can't even,
You get the same information.
I can't get the data open either.
Oh.
Yeah, how do you get the data open?
Clearly I don't know.
Um,
I just clicked on it and it opened.
I think I have to change it back to Excel then.
So the top part will have Excel stuff and then the bottom half will have SPSS.
is that where you're at, Nanette?
No.
Oh.
If I data, SPSS, help tools.
Let's see.
Okay, oh, now I think, hold on just a sec. I had to change it back to let's see if it works. It's chapter 12.
Okay.
Got it. Sorry.
Oh, good. I just sent you the link for the statistics page that has the data.
For mine? Okay.
Let's see. Okay, so now we're going on to B. Right?
Yeah.
Okay, so let's bring that up. And let's transform that. Oh, wait, let me just make sure. I take that out.
Okay, make a column of differences. This data comes from.
Okay.
Which is greater, sample difference or the degree of freedom?
Let's see.
Well, the sample would be greater, right? Because the degree of freedom is always one less.
Yes.
So, yes.
Isn't that right?
Put the information.
And that doesn't change. That's always the same.
Yeah, N is 22 and DF is 21.
Yep. Let me go back to that.
Okay, so which is greater? Second. Hypotheses different than 0, and you use a level, so again, 0, 1. What is the p-value?
What is the p-value?
When we have the level of significance, we don't need to change anything, though, to get the p-value, right?
No, all they're showing us in this is that the mean is just showing the difference. They're just showing that that it's not equal to 0. So we're looking for a two-tailed. So we don't need to do anything to the piece or to
Okay. So I got 0.001.
Yep, me too.
So once I have my spreadsheet open with the info, I have to take it and connect it into the other data, right? No?
I'm having a hard time hearing you, Minette. What did you say?
Yeah, I can't hear you either.
Oh, sorry. Once I have my spreadsheet open with the information, you hear me now?
Yeah.
I can hear you. I can hear you trying to talk, but there's a pretty big echo, so it's going to get lost. What you're saying is getting lost in the echo.
I'm saying, do I need to paste it and put it into the other data sheet?
Yes.
But which one is it? I can't find it.
So click on the first one that'll come up will be the one sample t-test, and then the next tab is the paired sample t-test. You're going to want to click on that and then put the data in. But put column 1 in variable 2, column 2 in variable 1.
All the way down level 0.
Does that make sense?
Yeah. I went all the way down to level 0 to level 3 for my base. No.
James, there's a little bit of feedback on the sound from you here, so I need you to...
Okay. Sorry to go back to 4. I have a question about it again.
Okay.
So it's asking, it says the probability of being greater than 2 is 0.0403. And then it says to use HA, so I'm guessing in the previous question, which tells us that we're looking just for the difference, not for greater. So it sounds like I've actually got it reversed. So they're giving us that the probability of 2 being greater.
So I was wondering if it wouldn't just be that answer, what it gave us, 0.0403.
See, that's what I was wondering. Because when you put it into the to SPSS or to Excel for me, it comes up as the same thing.
Okay, can you do me a favor on Excel?
Yes.
Instead of putting greater than, change it to equal to, or not equal to, whatever the.
Yeah, that's.
What does that change? Does that change the p-value?
Where'd you go? Let me put this information back in.
Okay.
9.
I mean, is that our answer? 0.0403?
I think that's the answer if it's greater than 2, but it wants us to look at the above question and show that that we're not looking for greater than, we're looking for a difference.
Oh.
But
So
if we're
then
looking
we
for
want.
difference, then we divide by 2. But if we're not looking for difference, is that just our answer?
No, if we are looking for greater or less, we divide by 2.
Right.
So if we're not,
So
if we're not
looking for that,
if
it would
we're
almost
not,
be times 2.
it doubles it
then
up.
is that our answer? 0.0403.
I think it would be double that. That's
So
what
if
I
I
was
put
having
it,
to check in.
if I put it to not equal to, it doubles it.
That's
If
what
it's, let's see, if it's greater than, it's the same, and if it's, oops, sorry, if it's less than, it's a completely different number entirely.
That's what I think the number is. Because it's
So
not, it's already giving us the number for greater than, but in this test statistic that it's showing us in number 3, the alternative hypothesis is not asking for greater than, it's asking for just what is the difference, or it's different than 0. In which case, they're showing us what it would be, so if we then change that to...
Oh.
Yeah, I see what you're saying.
I see.
So 0.
To not equal to.
That's what I'm thinking it is. 0.0806 is what it would be.
So
yeah, that
the
makes
p-value
sense.
that it pops up on in Excel is 0.0805.
But that's close, and it give or take, right?
Yeah.
But if we just double that, it would be 6.
So which one do we put?
You know what? Let's put the 5. Because if it divided it in some way, maybe that's where it would round up to 3. Does that make sense?
That's true.
Let's see.
0.0805.
Well, we're rounding to 3 decimals, so do we make it, either way would make it 0.81.
Yes. So it would be 0.
Okay.
So it wouldn't matter either way,
Woo!
right?
Yeah.
Yeah, it wouldn't matter.
Thank you.
That made me so nervous, but we're gonna get it wrong.
I know.
And hopefully we won't.
This is why it takes all 4 brains for us to figure this out.
Seriously.
No.
Probably only 3.
Okay.
So it's 0.08051. No.
So it's 0.081.
0.081.
Yeah.
Oh, I see, because you're rounding up.
Because, yeah, whether it was 6 or 5, we would round it 1 anyway.
Okay, so Ruth, can you explain that one more time, how you arrived at that? You said times it by 2. Is that correct, instead of dividing it by 2?
Yes. So you would double the number. So we're using the information found in problem 3.
Okay.
And so problem 3 gives us the alternative hypothesis as different than 0, which means it would be a 2-tailed test. So in number 4, it gives us the p-value for a 1-tailed test.
Oh, I see.
So then it's asking us to use the alternative hypothesis in 3 to get the p-value for the test of in question 3, which we would then double the p-value.
Perfect. Okay. I understand.
Just see here.
So then for 12, we're still good on 0.001?
Yes.
Okay.
On 11,
Then
do we put n is greater than yes?
Yes.
Yes.
Okay.
13 is rejectional, and 14 is decrease, right?
That's what I put.
Okay.
Okay, what was
Does that sound right, Ruth?
See, you decide to try another alternative hypothesis. This time you use, let's see, the mean is greater than 0, and you keep the same level of significance. Did the p-value increase or decrease? it would decrease
Okay.
Right.
because you would divide it by 2.
Because
Okay.
you're dividing, but yeah, 2.
Yeah.
And so you would still reject the null
Yeah, because it's still
Yes.
on 15. Yeah.
Then for 16, the lowest we could get then is the first one if it's greater than 0, because that's when we would divide it by 2. Whereas less than 0 or equal to, we would
As we have seen, the p-value depends on the
times it by
alternative
2.
hypothesis. So inside the data in this problem, do you think a general rule can be made with alternative hypothesis with almost p-value?
So, yeah, this is interesting because I would have said it would have been
I would say C.
I would have said A or C. Because B is a two-tailed test.
Right.
Mm-hmm.
So I would have said it would have been A or C.
Let's find out.
Can you go back? Sorry, can you go back to 12?
Yeah.
Hypothesis
Mm-hmm.
equals to 0. The level of significance is 0, 1 was the p-value, but nothing in the choice. So in data,
So we got, as the p-value for 12, we got 0.001.
gosh, how did you get this?
We ran the numbers through SPSS.
Okay, I'm on Excel and I put in all the information and it gave me 0.999. Oh, 0.001.
Yes.
Yeah.
Is that what you're looking for?
The only thing that I can think of is less than 0 would make it a negative number. But that doesn't necessarily, I mean, does that really change the p-score?
I think. Shoot.
Because just by like using the power of deduction, I guess. My best guess would either be C or D. Because you would be finding a p-value that's less than 0, or you would just not have enough information that it would depend on the problem. The one thing that we do know, the one rule that we do know is true, is that anything that's greater or lesser than just finding a difference is going to be half of what the p-score is for the difference.
Right. So which one is it?
You know, take your Excel and use a higher p-score. So do a p-score of say 20, and then use that as equal to if you are able to get a p-score of a high p-score, and then change it between higher and lower and see if that changes it at all.
So it does. Here's the only issue.
Because I think greater than or less than is going to be the same, right?
That's what I would think. The only thing that would change, like, well, no, it wouldn't. It would. You're right. It wouldn't even change the. It wouldn't change it to a lesser or negative, because when you change a z-score to a negative or a positive, and you highlight the greater than, it doesn't change. It's the same score as if you were to just highlight the lower than.
Right.
So this
So I would say
it's So, um, hmm. So is this one equal to the null? Okay. I think it might be less than 0 then, because when I put it in here, that seems to be...
You know what? I think you're right that it would be less than 0, because less than 0 would bring you as close to 0 as possible.
Which would bring you the smaller p-value.
Yeah. But you can't ever get a true 0. It would end up being 0, 0. I can't remember. So you can't go into the negative with the p-score. So it would, you know how it ends up being that 0, 0, 0, 0, 0 something to.
Right.
But you can't ever get out that far, and so it brings it back to close to 0. I don't know. It's that or not enough information, and depends on the problem.
Yeah, I agree.
Does the book say anything?
That's what I was going to say. I was going to go back to the
Okay.
book and see if it said something.
Well, I was trying to read through it, and I didn't see anything that talked about that.
You know what? In the area, it says the area left to t under the curve. This area is so small it's not illustrated on the plot. Please note that this image was taken from, okay, t. It's so important to note that only the left tail is shaded, even though you can't see the illustration. Since the p-value is less than the level of significance, we reject the null. That doesn't, you're right, it doesn't really give us a lot to go off of in terms of p-value. I wish it gave us something a little bit more definitive.
The only thing I can think of is because on 14, the p-value decreased.
Right.
So would that then mean if it's that one, it always decreases like that?
Well, it would decrease whether we did a greater or a less than. Because it would.
That's true.
Either way, we're going to be shading. You know, if we put the value into the applet, we'd either be shading to greater than, which is to the right, or we'd be shading to the left. But in which case they would be the same. The only thing that I can think of in my mind is that with these tests you can never get 0. It's always the lowest you can get is close to 0. But I can't see how that would change between being greater or less than. Boys, can you give me a moment? Okay, why don't we let's do 17 and 18 and then let's come back and think about that one.
Okay.
Okay.
So these ones, I got negative 18.607
Oh,
for the lower bound,
That's what I got.
Yep.
negative 5.303 for the upper bound.
can you tell me how you got that?
So it should just show the confidence interval, the lower and upper.
Yeah, for the data from the second
Yeah.
chapter, right? So I
Yeah.
just put all that in, and it gave me confidence level of negative 7.209 lower. In confidence.
Did you put the 69, 34, 39, 30 in variable 2?
Oh, no, I put in variable 1. Sorry.
Yeah.
Oh, okay. Sorry. I forgot to switch them.
I think 16 is A. Maybe I'm completely wrong, but it says, as we have seen, the p-value depends on the alternative hypothesis. And in 14, it decreased when it was the alternative is greater than 0.
Oh.
But if the alternative was less than, it would decrease also, right?
Yeah. That's
Huh, shoot, I don't know. Maybe so.
Because then we divide, either way we divide it by 2.
So not enough information? Oh, I don't know.
I know, I don't know. And
Oh.
I've looked through all my notes and read through the book, and I can't find anything.
You know what was 17 again? 18.5?
So I got for 18 negative 5.303.
a negative 0.503 for what? Oh, I see what you're saying. Okay, so let's just think about this for a second. So we look at 12, and we have our alternative our hypothesis, which is giving us a difference of 0, and our p-value for that. Give me a second. Let me just see where we're going. No, this is going to answer. Okay. So question 16 is included in the data that we have for data B.
But it
Chapter
says,
data.
setting aside the data in this problem.
Yeah.
Dang it. I was on the side.
Sorry.
I think a general rule can be made.
Ladies, I just don't know. I don't know what the answer is. I'm lost.
Number 7.
I think it would be, then I think it would be not enough information. It depends on the problem. If they're telling us to set the data aside, it would depend on the problem. It would depend on what they're asking us in the problem.
I say, I'll go with that. I give up.
What did you decide?
Not enough information, that it would depend on the problem. If they're telling us to set the data aside, then what it's asking us, so what do you think a general rule can be made? And then it's asking us which alternative hypothesis would give us the smallest p-value. It would depend on the problem.
See, that's what I'm thinking, because I'm thinking greater or less than would be the same.
But then it would depend on if the problem is asking you for greater or less than.
Or greater or less than, or just different, yeah.
Yeah, so I think if the problem was asking you for just a difference, we already know that greater or less than would give us a lower p-score. But if in a case of a greater or less than question, It would just be if they're asking us for greater or less than. That's my best guess. But I'm starting to talk myself into circles, which makes me kind of get crazy because I'm like,
Right.
I feel like the answer is right there, and I don't know.
There's not enough information.
There you go, not enough information. If you're telling us to throw everything out, there's not enough information.
I'm gonna go with it.
Okay,
that,
should we
Nanette?
go over all the problems real quick?
Yes, let's go over the problems.
One more time.
Yeah.
So for number 3, we put what is the value of statistic 2.0,
Yes.
and number 4, 0.081.
Yep.
I can't hear you.
0.081.
Can you hear her
Okay.
pretty good, Karina?
Yeah, I can hear. Can
Okay.
everyone hear me?
We can hear you.
Yeah, I can hear you.
Okay. Do you want me to read them?
Yeah, I think that would be good.
Okay. So 5 is negative 31.025.
Okay.
6 is 341.157. 7 is negative 0.407. 8 is 0.689. 9 is fail to reject. 10 is fail to reject. 11 is N, as in Nancy. 12 is 0.001. 13 is reject. 14 is decrease. 15 is reject. 16 is I'm going with not enough information because I give up. And then 17 is negative 18.607. And then 18 is negative 5.303.
Oh,
Okay, we ready?
Is everyone good? Let's go for it. Woohoo! I knew there wasn't enough information.
Yay! Oh my gosh.
Oh, that was.
I know, I kept going.
good.
Yeah. That was a tricky one.
It took a lot of.
But obviously you figured out 4, so.
Oh, I'm glad. I'm glad. That one made me a little nervous, but I'm glad.
Oh, that was so awesome. Thank you. Sweet. Well.
That does definitely leave us on a high, ladies.
Yes, that's good.
Okay.
So,
Time,
I'm
same
going to
place
stop
for Thursday.
broadcast, and then Karina, you tell us how he proposed.
Okay.
Oh, yeah.